Hello friends, welcome back to the channel. In this video we will solve this problem related to the coefficient of friction on a sliding of body on a rough horizontal plane. So I request you, we have solved this kind of problem in case of inclined plane when body is lying on the inclined rough plane, right? So you watch that video. I suggest you to watch that video first and then come back to here. You can watch that video by clicking on the I button. So let's solve this problem. Read the problem statement. The minimum force required to slide a body of weight W on a horizontal rough plane is, so we have to find the minimum force that is required to apply on the body to slide that body on a rough horizontal plane. So let's first draw the free body diagram of this system. Let's say this is the body W, which is lying on the rough horizontal plane. Since it is a rough horizontal plane, some coefficient of friction of the surface is, let's say, mu. Coefficient of friction of the surface is, let's say, mu, right? So when this body is in static equilibrium condition, the various forces which are acting on this is, one of the forces is gravitational force or its weight, force due to its weight, that is W, right? Now this W will be compensated by the normal reaction force offered by the ground, so which is equivalent to normal reaction force, which is opposing the body weight, right? So these two are the compensating force. Let's say we apply the force F, minimum force F, to move this body on right hand side, So the frictional force which is due to the rough surface will oppose the movement of the body, and it will oppose by applying the frictional force called mu times Rn. If our normal force is Rn, then frictional force which will oppose the movement of the body will be equivalent to mu times Rn. So this is our frictional force, right? So this is the free body diagram of the system. We have to find the minimum force F in such a way that the body will slide, right? So let's do the equilibrium of this system. For equilibrium of this system, the horizontal force F is equals to the horizontal force mu times Rn. Both are same, but the direction is opposite, so mu times Rn. Now let's say if we want to find out the equivalent force of these two, so let's say resultant force of these two is, let's say, R. Resultant force of these two is R. If we transfer this force over here, mu times Rn, then it will give us here mu times Rn, and this triangle, diagonal of this triangle, will give us the resultant force, and this will be the theta. Theta is nothing but the angle which is making the resultant with the normal force, right? So if we apply the tan theta over here, then tan theta is equals to the opposite side mu Rn divided by the near side, that is Rn, right? So let's say this is our equation number 1. Applying the tan theta tangent, to triangle, tan theta is equals to mu times Rn divided by Rn. Rn is nothing but the normal reaction force. So Rn got cancel out. So mu is equals to tan theta. Mu is equals to tan theta. And if we apply the equilibrium of the vertical forces, equilibrium of the vertical forces, then vertical force acting in downward direction W is equals to vertical force acting upward Rn. So this is our another equation. Now put the value of mu into equation 1 and value of equation 2 into equation 1. We got to minimum force F is equals to mu is equals to tan theta and Rn is equals to W. So our answer would be W into tan theta. Right? I hope you got the concept of coefficient of friction. Do like, share and subscribe to my channel for such a more content. And if you have watched the video up to this point, then I suggest you to give the thumbs up to this video and hit the bell icon for latest notification. Thank you. We'll see you in the next video.